is about diagrams and Pythagoras. You will recognize it from grade 11, the if, then, calculate sums. So it's the if, determine sums. But in grade 12, we have double angles, compound angles, etc. Or double two cos diagrams, etc. in these type of sums. So the first example, we say if tan equals 3/4 and theta is between 180 degrees and 360 degrees, calculate the following sums. We need a cost diagram because we have to plot two clues on the cost diagram. The first clue is tan equals 3/4. Now you first have to determine whether it is a positive or a negative tan. Tan is 3/4, so it's positive. And where is tan positive? Here at A and T. Now you go to the second clue. Theta must be between 180 and 360. So it's the bottom two quadrants, 180 to 360. And the quadrant with the most ticks is the quadrant where you draw your triangle. Tan is opposite over adjacent. So it's opposite, which is 3, over adjacent, which is 4. But you have to look at your x and y values to see whether they are positive or negative. This is 4 on the x-axis, but what is 4's sign? Negative 4. This is 3 on the y-axis, and 3's sign is also negative. Now we have to calculate the hypotenuse of the triangle, and we're going to do it with Pythagoras. Let's name it r. R squared equals x squared, which is minus 4, plus y squared, which is minus 3, and we work with Pythagoras. So r squared will be 16 plus 9, and we get the square root on both sides, which is the square root of 25. Now from grade 10 onwards, the answer of a square root is either positive or negative, and the square root of 25 is 5. But look at your graph, your cos diagram. R is the hypotenuse, and the hypotenuse is always positive. So you have to write R is a positive 5, and you put it in your graph. Now we have all three sides, and now we can do the sums. The first sum is sine 2 theta. This is a double angle, so we repeat that little recipe for sine 2 theta. 2 sine theta cos theta. And now you just substitute the values. 2 is 2 over 1. Sine theta, opposite of our hypotenuse, minus 3 over 5. Cos theta is minus 4 over 5. And If you type that into your calculator, you'll get an answer of 24 over 25. Any questions here? The next sum, cos 2 theta. It's also a double angle, and you can have one of three choices. So let's take the 2 cos squared theta minus 1 choice. Any other choice will give you the same answer. So it's 2 over 1 times cos theta. Cos theta is minus 4 over 5, but it must be squared, minus 1. And your answer for that is 7 over 25. Our third example, tan of a certain angle. You learned an identity in grade 10. Tan is sine over cos. So it's sine 2 theta over cos 2 theta. We calculated sine 2 theta in number A. It's 24 over 25. This over line means it's divided by cos 2 theta, and cos 2 theta is 7 over 25. This becomes 24 over 25. The divide becomes a multiply, and we swap that term. 25 over 7. The 25's cancel out, and our answer is 24 over 7. Any questions? Can I carry on?
So ma'am, because there's no like way to calculate, like why can't you just say tan is opposite of adjacent?
Because we have a 2 theta, not a theta. So this is a double angle. Okay. Our next example, and this is a typical question that grade 12 will get. The one that we just did was a typical grade 11 question. Now we have two angles, an alpha and a beta. So we're going to need two cost diagrams. Let's look at our first angles clues. Sine alpha is 3 over 5. That is a positive answer. So where is sine positive? On the top two quadrants. Alpha is between 90 degrees and 270 degrees. So it's from there till there. So it's the left-hand side's quadrants. And where are the most ticks? Second quadrant. So my triangle will lie here. And it is alpha. Sine is opposite over hypotenuse. Opposite over hypotenuse. Quickly look if you need to put in a negative somewhere. The 3 is a positive because it's y and it's above the x-axis. The hypotenuse is always positive and we need to work out x. So we're going to use Pythagoras again. X squared equals the hypotenuse squared minus 3 squared. 25 minus 9 is 16. So x will be the square root of 16. The answer of a square root is always positive or negative. 4. Now you have to look at your diagram. The x is on this side, so what will it be, a positive or a negative? Negative 4. Therefore, x is negative 4. You have to write this and to put in your negative 4 on your diagram. Now we look at our second angle. Cos beta. Cos is positive. Cos is positive on the first and the fourth quadrant. Then you look at your degrees between 180 and 360. So it's at the bottom. The quadrant with the most ticks is the one with the triangle. And we're working with beta. It's adjacent over hypotenuse. So the adjacent is 12 and the hypotenuse is 13. Are any of those negative values? No. Hypotenuse is always positive. This one will be negative, but we have to calculate that. So y squared equals the hypotenuse squared minus one side squared, and we used Pythagoras. So 13 squared is 169 minus 144, and that gives you 25. So y will be the square root of 25. Therefore, y will be positive or negative 5. Look at your graph diagram. Which one will be y? The negative 5. And you write it in. Now that you have both your triangles and all three sides in both triangles, you can start doing your sums. The first one is sine alpha minus beta. So it's a compound angle. What is the recipe for sine compound angles? Sin cos, same sign, cos sin. Okay. Sine alpha is 3 over 5. They gave it to us. Cos beta is 12 over 13 minus cos alpha minus 4 over 5 sine beta minus 5 over 13, and you type that exactly as it is on your calculator and you get 16 over 65. Now we do the next one. What is the formula for cos compound angles? Cos, cos alpha, cos beta, change the sign, sine alpha, sine beta. Cos alpha is minus 4 over 5, cos beta 12 over 13 minus sine alpha 3 over 5 sine beta minus 5 over 13. Type this in and you get negative 33 over 65. Number C. This is our co-function. Can you remember co-functions from last year? Who doesn't remember? It's the 90 degrees minus or the 90 degrees plus. With co-functions, we need a 90 degree minus a unit, but there are two angles. So let's put that as a unit. So let's just rewrite that as cos 90 degrees minus alpha minus beta. I took out a negative, that's why the sign changes. Now I have a 90 minus something, and I use my co-function. Cos changes to sine, and we use that angle. Now we have sine alpha minus beta. We did that sum in number A, and it's 16 over 65.
Why did the alpha and the beta go from plus to minus?
Okay, I took out the minus and I put them in brackets. So minus times a plus gives me a minus, and the minus times a minus gives me a plus. Okay. Any questions on this example? The next 2 or 3 examples are not in your notes, so you have to copy them. It's half angles. Now we know that double angles of sine is 2 sine theta cos theta. Yes. We want to change this half angle to look like a double angle. So we have to do a little bit of magic here. I'm going to change this sine half something to sine 2 something. So if I multiply these two, I must get theta over 2. So what must this be then? A quarter. Theta over 4. Because if you multiply 2 over 1 with theta over 4, 2 goes in once, 2 goes in twice, you'll end up with a half theta. Okay. And when you have a double angle pattern, you can use this formula. So it will be 2 sine theta over 4 times cos theta over 4. Okay, so don't be fooled or get stuck in a big sum when they put in a half somewhere. You can change that to a double angle, and then you use the recipe for the double angle. Okay, let's look at the cos one. We know that cos 2 alpha equals 2 cos squared alpha minus 1, or the other two possibilities. So I'm going to change this half angle to a double angle. Cos 2. Again, I have to multiply it with alpha over 4. If I multiply these two, I will get alpha over 2. And now I can just use this formula to get my answer. 2 cos squared alpha over 4 minus 1. Any questions? Okay, that is today's lesson. Your homework for tomorrow is exercise 5, page 14 of the notes, number 1, 3, and 5.